All right, so hey everybody, time for another Learning Elisp video. It's been a little over a week or a couple of weeks since my last videos were out. Sorry about that. We started painting the apartment. It was about time. You could ignore that alert just that came up in the corner. That was just a that was also something that I dealt with last week. As you know, I'm retired, but I had to pinch hit for a buddy of mine who is teaching our teaching methods course in our teacher preparation program, or what used to be my teacher preparation program prior to retirement. But that's just an alert because I had to join the various Slack channels and forgot to turn them off. So anything you see in the corner there, ignore. But anyway, we also were painting the apartment last week, or at least painting the living room last week, and things are mostly back in order. But I had to take down, I was working off my laptop and had to take down my recording setup. So sorry about that, but now it's time to get back into the swing of things. So what we're going to look at today is a few functions or a couple of functions, introduce some new concepts, start building something that's ostensibly useful. It's not really useful because it's already built into Emacs, but I think it'll still be a fun little thing. Basically, we are going to work on something known as Rot13. And also, you'll notice here that the file name is rot13.el, and .el is the normal extension for an Elisp file. So we're going to put this in a file for two reasons. One is so I can put this up on GitLab, and I'll post the link. So this will slowly build as the series progresses, but also because then we can load it into other, when we load Emacs, we can then say, hey, I want these functions. Ultimately, this can go into creating packages. So up here, I put these double semicolons, and semicolon is for a comment in Elisp. And basically, you'll note here, I am in an Elisp is the mode for this. So this is a comment. Usually it's double. And usually I'll put a double because for a lot of Lisp modes, and I don't remember if Elisp mode does this, if you just use a single comment, it'll tab it way over because the intent is kind of like old assembly language where you'd put the comments on the right-hand side. But anyway, we're going to do Rot13, and I'll explain what that is, and I'm also going to talk a little bit about some of the history behind it. So I might ramble on for a bit, but what I will do is I'm just keeping an eye on the time here. What I'll do is in the video description, if I spend more than like a minute on the description, if I start rambling on for 5-10 minutes, if you don't want to hear my rant about internet history, I'll put a link to skip till later in the video for when the coding starts. But Rot13, or Rot13, it stands for Rotate 13, and it's a specific instance of a Caesar cipher. And a Caesar cipher is a rotational cipher. The idea is that if you have the letter A and you rotate it by 2, A would become C. B would become D. So ABC would become DEF. Or actually, that's rotating by 3. A, B, C, D. So this is rotate by 3. And it's a pretty simple operation, but the reason why it's a little bit interesting or tricky is when you get to Z, Z would go back to Z, it would rotate around to A and then B and then C. Z becomes A, B, C, rotate by 3. And that's something you have to pay attention to because in most computers, or in all computers that I'm aware of, letters are usually stored, or characters are stored using a numeric code. And the code for, it's not 26 letters, 0 through 25 or 1 through 26. Lowercase a happens to start at 97, And uppercase A starts at 65. So A is 97, B is 98, etc. And then when we get to Z, it's got to wrap around to 97. So that's something we're going to have to deal with. And this is usually, I love these rotational ciphers or Caesar ciphers because it's like a gateway when you're teaching programming. Because it's not encryption, it's not really encryption because, there's no key, it's not secure in any way, but it's kind of a gateway to encryption. I also like it because it's kind of a gateway to other subjects, to data analysis and to machine learning and to, to lots of stuff. What I actually do is I do a series of lessons where we first learn how to do a rotational cipher, but then when we have something that is rotated, can we write a computer program that will decode it? And what we ultimately do is we do a statistical analysis of letter frequencies, because it turns out that in an English sentence, certain letters appear more frequently than others. And so if we have this rotated or this quote encrypted string and we rotate it through all the 26 permutations, one of those 26 rotations will be most like an English sentence because it has, more E's than it has Q's, because E is the most frequent letter and Q is one of the least frequent. And we do this, so it's really using basic high school math to do this. It's really, really cool. It's also cool because you can look up the frequencies by, just searching English letter frequencies, or you can download a book from somewhere like from Project Gutenberg and learn the frequencies by counting the frequencies in an existing text. It's also really cool because you can also do the same thing, like you can download a French language text and then you can do the same thing on French. And it's further cool because it doesn't work if you just try to rotate good and make it into, it won't decode good because there's not enough letters to find the frequencies. You need a certain amount of data. So I love this rotational cipher thing because it's just a gateway to so many cool computer science concepts. Now, the specific rotation we're going to do is Rot13. And Rot13 is very common because it's halfway in the alphabet. And the cool thing there is and I said, this is all built into Emacs. So if I have hello world, and I can actually mark this and, whoops. And I can say Rot13 region, and it rotates that region. It's rotated at 13 characters. And then if I do it again to these rotated characters, it brings it back. Since 13 is halfway, if you Rot13 something, it goes to something that looks like gibberish, but then if you do it again, it quote decodes it. Now, Emacs has a couple other cool Rot13 things, so built in. So there's also Rot13 mode. So if we're this is in Rot13 mode, I don't even know if I'm writing this right. And I now do Rot13 to turn off the mode, it can turn off the mode. Or I can say Rot13 other window, and this shows the other window being Rot13. So it's just kind of, it's all built in. So what we're going to write, let me just go to, I killed the buffer by mistake, so anyway, and we're not going to use love, so we can make it big. So Rot13, it's built in, but why is it built in? Who uses it? And that goes back to at least for me, some internet history. So I was on the internet back in the 80s when I started college. I unofficially had a little access before college, but my first accounts on internet-based systems was when I was at NYU, and actually not everybody got it, but I specifically got a job in one of the computer labs, so I could get an account, so I could be in touch with my few friends who had things, had email and whatever on other systems. And unfortunately, there actually wasn't a position available, but I knew somebody who was a year ahead of me, and he basically dropped 1 hour from his work so I could get the job. And it's funny how life works, because he then transferred to another college after that year, and I ended up getting a full-time job running the computer facilities for NYU's business school undergraduate division, which paid my way through school, and I was able to afford my way through college, and that was the start of my career. Starting from that 1 hour a week, which I merely took to get an account on the internet. Well, the internet back then had this thing called Usenet News. And Usenet News were news groups. It was basically like, think of it like Reddit. But the interesting thing about it, and just a reminder, I will put a link to the end of this section so you can skip all of this. Think of it like Reddit, but distributed. And the idea was all of these computers and these that had Usenet News, they would store and forward information. And what would happen is, the machine would have certain news groups that you could have discussions on, and then a few times a day or overnight or whenever, it would connect with other computers, and they would say, hey, do you have any new news for me? Here's the new stuff, the new replies and the new posts that I have for you, and it would spread it around, and it was totally distributed. And some of these news groups were, were text, so you'd have things like, Comp OS, well, eventually you get Comp OS Linux, Comp OS Unix, you'd have Comp Lang C. You would not have Comp Lang Java because there was no Java. But this would be the comp hierarchy. And then there might be Sci Physics on the physics hierarchy. And then there could be like rec.sport. Football, or rec.sport. Fencing, or actually, there may not have been a fencing group. I don't remember. I did fence, but I don't remember. But there were all of these groups that you could subscribe to, and then there were also the alt ones. And alt ones, the official ones, so you might have alt.sport.basketball.New York Knicks. I'm pretty sure that was one of them. And Comp and Rec and Sci and a couple of others were the official ones, and most places had those, and those were created officially through whatever the mechanism was. But anyone could create an alt one, and whether or not it caught on and other people would carry it is something else. And I could be a little bit off on my facts here. I apologize. It was a long time ago. Now, so this was totally distributed. The other thing here is there was also text communication, like these were all like little text messages, like a listserv, or like Reddit is the best analogy, but distributed Reddit. And there were also binaries groups, and that's where, let's say, some of the less up and up activities occurred. The interesting thing is this happened, this type of, it had all these questions of ownership because it was distributed. Like, if my server gets all .binaries.illegal stuff, am I responsible? Because I don't really do anything with it. I'm just passing it through blindly. And that was the same instance of Napster a few years later. And an interesting thing is we had this, we keep trying to decentralize. I say, if we decentralize, it'll be, we can democratize the internet and things will be better and open and whatever. But we went from this totally open system to Reddit, and we see this over and over and over again. And I'm digressing a little bit. We had like Git. It's distributed, totally distributed. It's great. Everyone has ownership of it. It's a share, and then we all put the stuff on GitHub. So it's kind of funny now that we have blockchain and all of that, and it's like, it's going to be decentralized and anonymous, blah 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 blah, until it's going to all be centralized by one player. So interesting things going on there. But going back to these this Usenet news, one of my favorite was Rec Humor. And Rec Humor was for jokes, and it was an unmoderated group that everyone can post jokes to. And to the point, it was the Wild West that they came up with Rec Humor Funny, and I think there are still Rec Humor Funny archives out there. Rec Humor Funny, basically it's a poke at Rec Humor in a way, but it was moderated. So I don't remember if people submitted jokes to Rec Humor Funny or if they were pulled from Rec Humor. But in theory, it would have to cross a certain bar. There was also Rec Humor SPC, which was Rec Humor Stupid People's Court, and those of you of an age like me will remember the original Judge Wapner's People's Court, and this was a very funny take on that involving when there were flame wars being online arguments in news groups between people that happened in the day. I think you could probably, I forget if it was termed that way, but maybe Linus Torvalds' argument with Andy Tannenbaum on microarchitectures maybe could be considered one of those. I don't know, the brain is fuzzy, I'm an old man now. But anyway, you can also get, I'll put a link in my blog post to some of the Rec Humor SPC archives that I read when they came out. Like there was one great one on Saturday morning cartoons. But anyway, in Rec.Humor, what would happen is anyone could post anything, and as you all know with jokes, jokes are, some one man's meat is another man's poison. I might think a joke is hilarious, but you might think it's not only not funny, but offensive. And so they had to come up with a way to allow people to post things that were potentially offensive because they wanted to be open and free, but they didn't want to offend people. And that's where Rot13 came in. So what the standard was that if you're going to post something offensive, you would Rot13 your text and you would post it in the news group. And then what would happen is somebody would see a message and they would see, oh, this looks like gobbledygook, like gibberish. Oh, it must be an offensive joke. And so then if I want to read it, I know I might be offended, but then I can Rot13 it, and actually most of the newsreader programs had a single key that would do the Rot13, so you could easily encode it and then decode it, and then if you were offended, in theory, it was your own fault. And in fact, a lot of news readers, and Emacs, of course, had news readers. GNUs is the big one. GNUs is made as a news reader. I didn't use GNUs. I used another one under Emacs, and I forget which one it was. It's been a few years, it's been a lot of years. But literally, some of them would literally encode the message, but on the top you basically say Rot13 or something like that, and in the subject line it would not encode the subject, so that way people could see that without it being encoded. So anyway, that's where Rot13, it seems like a totally ridiculously silly utility, but it actually had a very practical use, and it was simple. And I guess it's like now under Reddit you can have like spoiler flags and you wouldn't show it unless you click it. It's a similar deal from back in the day. So anyway, let's get back to Rot13 as code. So it is now about 18 minutes into this video, and if you're rejoining us because you clicked to skip me ranting about history, welcome back, or not welcome back, you probably just clicked it and and found here. But we're going to get to writing our little Rot13 engine. And what we're going to do is we're not going to write it probably all today. We'll write a little bit of it today, and then we're going to make some enhancements to it, again, so we can explore Elisp a little at a time. So at the very start, we are going to want to write a function that will let us rotate a character by some offset. I'll just leave that, for now. So the idea is what we're going to want to do is the character. So for example, the character A has a value of 97, and it's pretty fluent in C. So what we're going to want to do is we're going to want to add to the character C our offset. The problem with this is after we add the offset, and this is not going to be finished, we are going to want to mod it by 26. The idea that Z has to rotate back to A. We need that rotational arithmetic. But the problem with this is this isn't going to work because lowercase a, and let's just do lowercase letters for now. Lowercase a is a 97. So if we want this to work with a mod 26 arithmetic, what we're going to want to do is we're going to subtract 97. And again, I still haven't played with puny mode, so let me disable it. Let's just do this. Let's just subtract 97 from C, and let's see what that gives us. So I'm going to evaluate that with Control X, Control E, and let's do rotate. And this is not going to work at first, but that's okay because I want to talk about things. Rotate A with 3, and you'll see it gives an error. Why? Because A is a string. And I don't want it to be, but I want it to be a character. So I'm going to quit the little debugger error message. And I can do this in a couple of ways for now. There is some stuff is automatic. But what I can do is I can say convert string to char A. And that's a little Elisp program. And you'll see here, that might not be what I want. That should have been what I wanted. But let's just see. Let me try something else here. Oh, C minus 97, that's correct. So C minus 97, it gives me 0, which is 97 minus 9. Well, actually, that shouldn't be right. Oh, no, it is right. I'm not using offset. I'm just doing 97. So this 3 is immaterial. If I do C, 0, 1, 2, so that's correct. So it's doing that subtraction. It's bringing it down to 0. Now, if I don't want to keep typing string to char, I can just say the character C, or the character A, the character B, the character C, etc. So what I'm going to do here is I'm going to subtract 97 from my character, bring it down to 0. So again, if I do A, it's going to be 0, B is going to be 1, C is going to be 2, etc. I'm going to add to that my offset. And so if I do that, we'll see that it's then adds the 3. So the lowercase a minus 97 brings it to 0, adds 3 to it. We then want to, now let's just do this with Z. You see, if it's Z, it took us to 28. It took us past the end of the alphabet. So that's where the mod, which is kind of like remainder does. So we're going to mod 26. And now that ZAB, 0, 1, 2, it's going to, or ZABC, it's going to rotate it around. And we're almost done because what we then want to do is add 97 back to it to bring it back up into the ASCII range. So if we rotate lowercase a by 3, it's going to bring us, as you can see on the bottom, and I know that's small, to D, which is what it should be, rotated 3 over. So we now have a very simple function that can do any number or any basic rotation. So now what we're going to want to do is we're going to want to rotate a string. And for that, I want to introduce a new function called mapcar. And what mapcar is what's known as a mapping function. And what a mapping function does, so let me write another function here just temporarily. Square. So if I say square of 5, it's 25. So just, that's it. Now, what mapcar will do is it basically goes through a list, and we'll define a list in a second, and it applies a function to every element in the list. So if I have a list, and for now we can do a list in Elisp like this. Actually, anything in parentheses is a list, so if I do plus 2, 3, that's a list which has a plus and a 2 and a 3. The problem with it is that Emacs is going to try to evaluate that with the plus function. And if we have a list like 1, 2, 3, 4, 5, that's not going to be good because it's like, what's the function 1 do? How can I do the function 1 on 2, 3, 4, 5? So we put a single quote in front of it. So now if I evaluate this, it says, no, we're not going to evaluate the function 1. Or even if we do the function plus here, it just says, hey, this is a list we're not evaluating. It's a list of data. We're treating it like data right now. So what I can do is I can say, let's do the mapcar function. What's mapcar? The square function. And well, if I write this, I don't think it's going to work. I'll explain in a minute. On the list 1, 2, 3, 4, 5. And it doesn't work because it's getting confused on the variable square. So I have to put the hash quote in front of it, which says this is a function, but we're going to evaluate it later. And you'll see on the bottom, it evaluates 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So basically what the map function does, or mapcar, if you're working in Clojure, or if you're working in Racket, Scheme, etc., it might just be called map. In a lot of languages, it's just called map for this particular version, but it's going to be mapcar in Elisp. So anyway, it's going to say, apply this function to every element in the list, and it's going to give you a new list. This is list processing, which is a very Lispy thing, very powerful. Now, there's another function that I can show you called the identity function. So if I type the identity function on 4, it just evaluates the 4. If I do the identity function on the letter A, it's just the letter A. And you'll see on the bottom, that's character 97. We're asking character 97. And it's the character A. So I can say mapcar, the identity function, on the list A, B, C, D, E. And you'll see on the bottom, it's 97, 98, 99, 100, 101. Mapcar will take a string and treat it as a list where each character is an item. And so you'll see 97 is the ASCII for A, and the 98 for B, et cetera, et cetera. So what we can do here, and these are going to be the last couple of things that I'm going to do for today, is we're going to write another function called rotate by 13 of C, and it'll just be rotate whatever we pass by 13. So if we say rotate by 13 A, that's going to change that to the N, which is the same as saying rotate A by 13, which takes us to the N. Now, why am I doing that? Because my mapcar needs a function that takes 1 parameter, and my rotate takes 2 parameters. So what I can now write is I can now write mapcar, the rotate 13 function that I just wrote, on A, B, C, D, E, hello. And you'll see how it works, 110, 111, 112, 113, 114. Then there's that 97 because of the space. I mean, and actually, let's just get rid of the space here. And then 114, so now I put the A, B, C, D, E, so we'll see some letters that are sequential, but then hello. And so that will apply rotate on every letter, but you'll see that it gives it to us as a list. Now, we can then use the concat function, and what concat does is it puts all the elements of the list back, and it builds it as, now it builds it back because they're characters as a string. And so our Rot13, our first version of Rot13 of a string would just be concat map car the rotate 13 function of our string. And so we can now say Rot13 of hello world, again ignoring the space. And then if we Rot13 it again, it translates it back. So that's a lot of stuff. And we are now up to, if you watch the whole thing, 30 minutes. So what I think we're going to do, well, I think I'm going to add one more thing, because if you didn't watch those like 10 minutes of me ranting, it won't be too long. But I think I'm going to add one more concept, because I want you to have seen it when we use it later. And that's something called a lambda function. And in Elisp, and in most Lisps and many other languages, you can do what's known as an anonymous function. So you can make a function like define square x times xx, like we did, but that's a named function. An anonymous function, usually known as a lambda function, is written by the term lambda and then parameters and then what it does, and that's a function. But it's anonymous. It doesn't have a name. It's not stored. So if we run this, well, lambda, you first have to spell it right. It just returns it as a function, but we can run it by then putting that. That'll give us the function, and then we'll apply that to 5, and notice it gives us the 25. And, well, you might say, well, why is that useful? Well, it may not be useful a lot of the time, because, or rather for like, if you're from like a language like C or a language that doesn't use it, but you're just like, well, why wouldn't I just give a name for the function? And that's because sometimes you just want to have some functionality as a function, as a throwaway. So for example, we might say map car lambda x times xx, and then we run it, and it's just a throwaway, and we just can write it on the fly, and then it's gone. Or like, no, we want a cube, and we write it, and it's on the fly, and it's done. So let's rename this, or let's just comment this one out. And let's write our new version of Rot13. And here what we're going to say, we're going to concat map car, but instead of doing that rotate 13, we're going to say lambda x. So we're just going to make an anonymous function. And what that function, or lambda c, we're going to say that function is going to call rotate of the character 3 by the offset 13. So it's just a wrapper to let us have that next parameter. And we're going to do that on our string s. Close it all out. And now we've redefined our Rot13, and if we just run this interior one, we get the rotated. But if we run the exterior one, we get the full hello world. So that still leaves us a lot more to do, but we're going to wrap it up here. So what we're going to do in the next video is we're going to do a couple of things. One, we're going to refine this program, because we have some good new concepts here. We have lambda, which is a tricky concept if you haven't seen it before. We got map car, we have dealing with characters. That's a lot of stuff. So in our next video, what we're going to do is we're going to add conditionals so that this will work on upper and lower case and ignore other characters. And then the other thing we're going to do is we're going to wrap it up into a function so you can put the cursor over a word and Rot13 that word. So it's not going to be quite like Rot13 the region like we saw that I demoed at the very beginning of this, but it'll be similar, and we're going to just add a little bit, and we'll get to that as well. All right, so a little bit of a longer one here today, but hope you enjoyed it. I'll put this code up on GitLab and get this out to all of you shortly, so enjoy.